This afternoon, I'm very excited to be sharing with you all how at ExxonMobil PNG, we are currently utilizing the technologies we have to collect the data we have in the field, in our facilities, bring those data up to a data center, train those data, and make operational decisions on those data. Thank you.
And good afternoon, everyone. My name is Jonathan Lanto, and I am from the autonomous region of Bougainville. I graduated from the Papua New Guinea University of Technology last year, and then joined the company in the same year, in March. So currently I'm working as the primary electrical engineer supporting the Heights gas conditioning plant and the PNG pipeline LNG sites. Today I hope to share some insights on how I and my fellow engineers use data to solve innovative problems. So from our introductory video, you can see that PNG LNG has not only helped launch an industry here in Papua New Guinea, but it has been setting production benchmarks across the world and also delivered more than 22 billion kina in revenue back into our country. So one of the key areas that I'd like to point out from our introductory video is the consistent annual production of over 8 million tons of LNG each year. And this is because this greatly exceeds our initial design capacity of the project. So this remarkable achievement is a result of our commitment to safe operations and innovative excellence. So today, Israel and I are here to share just a few key areas that we believe can drive value across all businesses in Papua New Guinea and abroad.
So data, as we all know, is the heart of any company, organization, or complex operation. As a company, the data that we generate from our processes and operations is one of the most significant assets we as a company own. And if we can unlock the potential power of those data that we have, we can gain significant value from it. So ExxonMobil is a global company, but it's also operating in PNG. And as a global company and also operating in PNG, it's continuously investing in newer technologies to make work more efficient for us. Some of these technologies include things like advanced process control, where we utilize computer logic to make best process decisions. As a result, we enhance our plant performances. Another technology we have a real-time optimization tool or software. So pretty much we're leveraging the data that comes from the field, from our processing facility, with production models that we have, and then we try to leverage those data, come up with a best model to better meet our consumer or customer needs. So as we're actively collecting those data and building a foundation where we can manage those data, this can now pave way for more enhanced technologies like machine learning. I don't know if you've heard of machine learning, but pretty much leveraging from statistical algorithms and patterns to drive the insights that we as a company have. And then also this enabled us to kind of earlier on detect protective measures so that we not only ensures that our plant continues to operate efficiently, but also safely and reliably.
So as an engineer, data is crucial to us. Why? Because we use this to make informative decisions, spot trends, and improve our processes. So when we get this data at the right time, we can use this or leverage this to design, develop, and maintain efficient systems, thereby facilitating innovation and drive technological progress. So through practical deployment of smart tools, as you see on the screens here, one of the things that we utilize is the connected tablets for recording data and for recording visual images in field, and also for obtaining information that is stored elsewhere or talk to our global experts that are located abroad. In addition to increasing data and availability or visibility, this greatly reduces our paperwork on site. So we have also been trialing immersive technologies such as RealWare to provide similar capabilities via hands-free operations on tasks where for safety reasons would require our operators to have two hands free. As shown in the hard hat with the integrated camera, that is an example of what a RealWare would look like. So one of the things that RealWare also promises is the leveraging augmented reality or live connections to remote experts via integrated headsets. So also one of the things that has been increasing on site is the use of drones for visual applications. This at site avoids our operators to work at heights whilst also eliminating the lengthy work effort for providing a safe environment for them to work in. So in addition, cloud-based technologies along with widespread internet has enabled swift data transfer between our experts or our field workers and our specialists, which significantly cuts down the number of time required for data collection, report generation, and then the transmission of these reports back to the relevant parties. So it has also had the potential to minimize the need for rework, as our field operators can now be able to provide additional information while being on site rather than having to revisit the site to gather more the required information that they would need. So a recent example, which you can see on the screen here, is the collection of our integrity data. So in here, we deployed a cloud-based platform where it provides the platform where our inspections are done on site, on digital forms that is, and then these digital forms can be submitted with the images that are taken with the tablet itself. So when on field, the inspection is done and the form is completed and then submitted, the resulting report is immediately available for validations by our integrity engineers. So this has greatly reduced the cycle time compared to our previous processes.
So to kind of further add on to Jonathan, and one of the technology we also have on site that enables us to connect those data quickly to the expert are wireless sensors. I don't know if you all know what a sensor is. So it's basically a device that collects analog data like pressure or temperature and brings them up for analyzation. So with wireless sensors now we can be able to, well, it has increased the amount of data we collect because we don't need to have our operators walk down to the field and then test and collect those data. Also, we don't need to have wired sensors. We can be able to collect those data, and then this in turn makes our work processes more efficient than before.
So historically, traditional data has meant that information has been trapped across individualized or specialized applications. So when we're trying to interrogate this data for insights, specialists would need to individually access these different applications in order to gather this data, right? But however, when we use cloud-based or cloud storages such as Microsoft Azure services, this has enabled for large-scale data lakes where all this information can be kept in one point of reference, so in which we can refer back and then see all this data in one location, right? So this data foundation is then core to effective visualization and analysis of our data, which provides the insights which enables us to innovate. And so when we have a question that we need an answer to, we would use visualization software such as Power BI. That's one of the softwares that we use, which aggregates or visualize the data available, or we use visualization software to interrogate time-based trends or investigate anomalies. So one of the examples that I would like to share with you guys this afternoon is an example of the need to better understand our performance of our remote sites generators. So these sites are remote in a sense that they are way up in the highlands, and they have been working like on a remote basis. So there's no way we can actually access those sites. So we are looking to get timely identification of potential issues or component failures, and then enable us prompt maintenance or repair times before larger problems occurs. So to have this real-time surveillance, we collect data on the generator's parameters such as power output, fuel consumptions, and then which enables us to optimize the generator's performance, and then identify potential for energy savings. And this is all done via a remote tapped-in dashboard.
So on that third point, another area of interest for us as a company is the ability to mine data. So the data that's coming from our processes and systems, through our deployed software platform, we can now be able to convert those raw enterprise data to a standardized data, and then this data can show us truly how our processes run. Once we have an understanding of how our processes run, we can start to dig deeper into our business KPIs to see where those bottlenecks, process deviations, patterns, and trends are. So through this, we can look across our business process and then see, say, maybe one bottleneck in our procurement process can affect our maintenance program, and then better optimize or make those processes more efficient. So another key technology we have, which is a very interesting one. If you've attended the session earlier this morning, Dr. Jane was speaking on digital twin. So it's deployed in different kinds of industries, medical industries. For us as a facility, processing facility, we also have deployed digital twin. So there are many interpretations and definitions of a digital twin. For the sake of this topic, it's basically a 3D representation of an object or a system, basically a human being now having a digital form in a digital environment. So I have a video here. So a key component of a digital twin is the ability to represent a physical object or a plant, live plant, in a 3D environment. While this is not our exact facility, we cannot show our exact facility due to proprietary reasons. This is very similar to the technologies we have in our facility. So with this tool, we can be able to have those metadata that's coming from the equipments, and then correlating that to other software platforms to give us a better understanding of our plant as well as our equipments. We can be able to do stuff like modeling our equipments, as you can see, in real time, of course. And then we can also be able to measure the distances of the equipments to enable us to work, if you want to do working at heights or any stuff that requires us to not walk down to the plant and actually do those work. Also, we can be able to measure and also plot coordinates of those equipments so that remotely we can be able to know where those equipments exactly are in that plant. And that enables us to do projects in 3D environment, simulate them to success before we actually go out to the field and do those projects. Okay, probably to the end. So to close, for closer, and I just want to share an observation as an engineer working in this wonderful company. ExxonMobil is a really wonderful company that ensures that we are utilizing the latest technologies, not only to ensure that all our employees work safely, but also we use those technologies also to make sure our plants running efficiently while sustainable approaches are taken to the surrounding environment and the communities that's nearby our facilities.